Lecture 4 span the tangent vector space. From the lecture 3, we obtained the differentials dx1, dx2, dx3. Remember that capital X is, in this case, a vector which belongs to the Cartesian coordinates, and this we calculated and we obtain, the basis vectors, partial respect to theta, partial respect to phi. You see, this here is, you can calculate this, you see that x1, x2, and x3 square is equal 1. This is a unit sphere. Now, recall that the curve gives numbers, labels, xi, which is a function of gamma of lambda. Lambda belongs to the real numbers. So given a curve, gamma of lambda in M, the composition xi, gamma of lambda, is a real value function. That's important here. This is this function here depends on the real value of lambda, the variable lambda. Now let f be a function, any function. So the partial derivative of f is, in this case, df is partial derivative of f with respect to capital Xi dxi. Attention now, all the calculations, they cannot be done on the labels. Remember that, That's why all the calculation we have to involve capital X, capital Xi, This is a covector A1 form. df is a covector as in one form as we showed in previous lectures, We are in part 8. We showed that this is a covector, one form covector. Let a smooth function, in this case, this smooth curve, be given by gamma lambda, x1 lambda, x2 lambda, x3 lambda, which belongs to R3, the real number, So this is equal, this number here, I just set labels on this. This is small x. Now, easily by chain rule, again, I will insist, we'll calculate it not on the labels. We calculate, just involve this case, the space R3, in this case, So that's why I set here capital X and not small x. Small xi, again, I will insist, is labels. I cannot resolve, differentials, on this labels point. That's clear for you now. So by chain rule, I just express, This over here is dxi d lambda partial f respect to xi. Remember that small x are labels. This here are numbers, That's very important here, All the calculation, again, I will insist, is done on this using capital Xi, see? So this dxi d lambda, this is equal this one, but this one, the number, this one, I calculate using capital X. I just wrote small x here, but the small x, I substitute by capital X and do the calculations. So this VI, the xi of the lambda, I define the components, of this vector V. D of the lambda is a vector V. So Vi, attention, dxi d lambda is represented but this derivative here, which this here, the derivative of small x respect to lambda, does not exist. Attention now, that's important here, okay? So in this example, for instance, I can span Vp, V at P, these are components, okay? This is for I is equal 1, this is for I is equal 2, okay? And this is the basis vectors. For instance, given the components 2 and 3, I just obtain the vector V, 2 partial respect to theta minus 3 partial respect to phi. Then given others, vector V theta and V phi, then on the same point P, I can obtain several, as many as I want, okay, vector Vp. That's why, because they belong to the tangent vector space at P. Remember that. I'm not involved any other point. It's just point P. If I want to involve other points, okay, on the manifold, I have to do the same procedure here, okay? This is independent of what we did here. This is another label, okay? Then I just represent small x by capital X, which is Cartesian coordinates, okay? I think this example shows clearly, okay, for you to avoid calculations on the label points.